Okay, guys, this is going to be 6-5. This is going to be the last section that's on your test, which is on Wednesday. We'll do this section today and, sorry, let's not say today. Let's say Friday and Monday, and then we'll have your test on Wednesday. Okay, so this is solving radical equations. So we're going to learn how to actually find answers to equations that have equal signs in them in this section. Each type of problem is fairly easy, but there are maybe 3 types of problems. You just have to understand the trick for each one. Okay, we will start fairly easy. We're trying to focus up there. Here we go. Okay, so the first one is going to be something like this. 3 plus the square root of 2x minus 3 equals 8. Okay, here's the strategy for solving anything that has a square root or a third root or any type of root. Strategy is this. Get the square root by itself. Okay, so the first thing we want to do is get the square root by itself. Now, let's make some rules here. These things that are under the square root are trapped here. You cannot, so at no time am I going to plus this 3 out of this square root. I cannot touch this 2x or the minus 3 until I cancel the square root out. It's trapped under this square root. I'll teach you how to get rid of that square root, obviously, but you cannot let these things trapped underneath here leave until you cancel the square root out, okay? So the very first goal is to get the square root by itself. So the first thing I want to do here, of course, is minus 3. I've got that the square root of 2x minus 3 is equal to 5. Okay, now again, if this is a normal problem that did not have this square root, then I would be adding this 3 over, okay? But this, right now, this 2x and the minus 3, like I said, is trapped under here. I need to use a mathematical strategy to get rid of the square root. So I'm always, when I'm solving, thinking about inverse or opposite operations. Okay, so what's the inverse operation of taking a square root? Well, the opposite of square root is squaring. So I'm simply just going to square both sides now. Okay, the square cancels out the square root. So I'm just left with what was underneath it, 2x minus 3. That has freed up this 2x minus 3. And of course, now I'm just equal to 25. Okay, and now I'll just, again, use inverse operations to solve the remaining problem. This is fairly easy from here. So when I divide by 2, I get that x equals 14. Okay, I don't know. You want to do another one of those? Okay, let's do another one of those by just kind of a little bit stepping it up a notch. I'll write it over here, but we'll be able to relate these two problems together. That way we can kind of knock 2 things out here. Okay, so it's 3 times the 5th root of x plus 1 to the 3rd. That was all under there, plus 1 equals 25. Okay. All right, so don't be scared of this thing. We will figure that out here in a second. Okay, so what I want to do is I want to get this thing by itself. All right, the first thing I would do to accomplish that is minus 1. I've got 3 times the 5th root of x plus 1 cubed is equal to 24. I still want to get this root by itself, so I'm going to divide by 3. And I've got that the 5th root of x plus 1, all of that's cubed, equals 8. Okay, now I'm just going to unwrap this thing. Okay, so first I'm going to get rid of the 5th root. The opposite of taking the 5th root is to put it to the 5th power. So I'm going to put this all to the 5th power first. The 5th power cancels out the 5th root. So I have x plus 1 to the 3rd equals, oh goodness, what's the 5th root of 8? That's going to be a pretty big number. Or sorry, what's 8 to the 5th? That's going to be a pretty big number. 32,768. Okay, now again, I can't touch this plus 1 until I get, because it's to the 3rd. I need to get rid of this to the 3rd. What's the opposite of to the 3rd? It's taking the 3rd root. So I'm going to take the 3rd root now of both sides. The 3rd root cancels out the to the 3rd, so I've got x plus 1 equals, okay, let's figure this out. The 3rd root, remember I do this on the calculator. You hit what type of root you want. I want the 3rd root. I go to math, and I scroll down to option 5 here, which is the x root. And when I hit that, it puts the 3 into the root number like I want. And then I'm going to type 32,768 This should be a whole number. I would assume this is a whole number. It is. It's 32. And then I'll just minus 1, and I get the x equals 31. Okay. Let's see. I think that I've got one other type like that I want to show you. Yep, right here. I got the square root of 3x plus 2 minus the square root of 2x plus 7 equals 0. That's my problem here. Now, I'm going to follow the process and the strategies that I've been talking to you about, which is get the square root by itself. Okay? And whichever way you think about it, my mind is thinking that I want to get this one by itself. So in order to get that by itself, I want to plus, since it's minus, I'm doing the opposite. I want to plus the square root of 2x plus 7 to the other side. So I have that the square root of 3x plus 2 is equal to the square root of 2x plus 7. Again, following along with the strategies that we've been talking about, the second that the square root's by itself, now I want to do the opposite of square root, which is squaring, to cancel that out. So I'm going to square both sides. This cancels out this square root, so I have 3x plus 2 equals. This cancels out this square root, so I have 2x plus 7, and now this is a very easy problem. I'll get my variables to one side by minusing 2x. I've got that x plus 2 equals 7, so I'll minus 2 to get that x equals 5. All right, last type of problem here. Last type of problem. Let me make sure that I find a good one for you. How about one? Oh, here's a good one. Not hard. Just got to learn the strategy here. It is x plus 1, and all of that is to the 3/2 power minus 2 equals 25. Okay, now, whatever has an exponent or a root on it, you want to get that thing by itself. So I want to get this thing by itself. That plus 1 is trapped in there until I get rid of this 3/2 power. So, of course, I want to add 2 first. So I've got that x plus 1 to the 3/2 power is equal to 27. Okay, now, here's what I want you to realize, okay? Anything, let's just side note here, okay? Any number or any letter, let's just say x. The letter x is to the first power, imaginary 1. So when something is to the first power, its exponent is invisible to us, okay? So if I want to get rid of this exponent, what I want to do is turn it into a 1, because then basically it's gone, okay? So what is the easiest way to turn a fraction to a 1? The easiest way to turn any fraction to a 1 is to multiply it by its inverse. So for instance, 3/4 times inverse 4/3 is equal to 12 over 12, which is 1. Okay? 5/3 times 3/5, its inverse, see, inverse is flipping the fraction, is 15 over 15, which is 1. Okay? So what I want to do is I want to use the exponent rule that deals with multiplication. The exponent rule that deals with multiplication is power to a power. So I want to put this to the inverse power to the 2/3 power, because 3/2 times 2/3 is 1. If I'm putting the left side to the 2/3 power, then I need to put the right side to the 2/3 power. So now this would be x plus 1 to the 6 over 6, or to the first, so that's just x plus 1, let's cancel each other out, is equal to, here we go, I'm on my calculator, 27 to the 2 over 3 power is equal to 9, and then I'll just minus 1, and I get that x equals 8. Okay, so whenever you're trying to cancel out a fraction exponent, just put both sides to that fraction's inverse, and it cancels each other out. All right? All right, that's all I got for you today. There's a harder type of problem, the hardest type of problem in this section. We're going to do that on Monday. Okay? See you tomorrow.